Hello, we have a wave propagating outward on the water surface. The water surface is an elastic medium. It's like a stretched bed sheet. So if any point in the medium is disturbed, the disturbance will be passed to the surrounding points, and that's how a wave ends up transferring energy and momentum. Please note that the medium itself does not propagate. So you look here, there's a water wave propagating rightward, right? Very clearly, there's a wave crest traveling rightward. But what about the water itself? The water itself is not traveling left to right. In fact, every point in the water is just doing a circular oscillation. You can stare at every point here, they are just doing a circular oscillation. This one is marked in blue to help you see even clearer. It's just doing a circular oscillation. But as each point in the medium does its oscillation about its own equilibrium position, a wave is propagated. You have probably experienced it before at the beach. Maybe you're bobbing up and down in the ocean here, right? Your friend could be bobbing up and down at this point here, and then a wave just sweeps through all of you. But do you all get washed to shore? No, right? You'll just continue to bob up and down at your own equilibrium position. So a wave can propagate in any elastic medium. A slinky is an elastic medium, right? So when I disturb one end of the slinky, what happens is the disturbance is propagated along the slinky. Again, it's the disturbance, the energy or the momentum that's being relayed down the line. The slinky itself is not traveling. Every part of the slinky just does a quick jerk, and then it returns to its equilibrium position. But the pulse gets propagated along because of this. You know, in the A level, we always start with the easiest things. So we are not going to do pulses. We are not going to do 2D waves on the water surface. We are going to do the simplest wave, which is a sinusoidal wave. So a sinusoidal wave has a very perfect sinusoidal wave profile. And also, if you are having a sinusoidal wave, it's because every point in your wave is doing a simple harmonic motion. Yeah, you can look at every point in this wave profile. It's just doing a perfect simple harmonic motion. And because of that, you get a wave traveling rightward. Now, the frequency of your SHM is also the frequency of the wave. As for the wavelength of the wave, it's just the crest to crest distance, yeah, from here to here. That's called the wavelength. Okay, so this is the starting point for the topic of waves. It's a fascinating topic. So see you. Ta-ta!